now we are recording. Again, this is an official statement that this class is being recorded. And it's all yours.
Welcome, everybody. My name is Honorable Lord Taran Saraev. I'm a plebe here in Trimaris, and I am happy to be teaching today. Medieval astronomy is one of the things I'm most interested in, and so I hope to be able to share some of that with you. If you have questions, please feel free to unmark yourself. I will try to pay attention to the chat, but sometimes when I'm sharing the screen, I don't always see the things that go on in the chat. So if someone does type in the chat, let me know. And as long as we're not all talking at once, feel free to interrupt me with questions, because some of the material may be dense, although not so much in this class, but especially in the last two classes of the day. So let's see here. Let me share my screen. All right. View. Slideshow. Cancel. Options always disappear when you're looking for them. Let's see here. All right. Everybody can see here that there's this, this is my first slide. It's a mosaic of God creating the world, at least from the Christian perspective. Astronomy was often viewed like this in the Middle Ages, and it's just kind of a nice, pretty opening slide. It's a 12th century mosaic. I guess I'll just have to proceed like this. This is not wanting to work at all.
I'm sorry, Taran, I had to step away. What's the problem? Can I help?
How's it looking for you? Can you see it at all, or do you still see my application?
I still see the application. Are you trying to go with the presentation view?
Yeah, I tried to start the slideshow view, and I guess it just didn't work.
Gotcha. I know what we have had to do before is if you start the presentation view, and then when you go to share the screen, you share the presentation view, not the program. I know that happens sometimes.
Okay, so let me unshare the screen then. Slideshow. I'm sorry for these technical difficulties, everybody. Let's see here. View. Guess I'm just gonna have to close this program. Oh, okay. Now back to Zoom. Try to share the screen again. How's this, everybody? Can we see it?
Yes, much better. Full screen.
All right, thank you. All right, so this is a mosaic of the creation of the world viewed from the Christian perspective. And you see here that the basic medieval view of the stars is preserved. You have circles upon circles upon circles, and a greater circle and a lesser circle. I thought it was just a nice way to kind of begin a discussion about astronomy for the SCA. My name is Taran Saraev. As I said earlier, my persona is that of a Mongol of the 13th, 14th century at the height of the empire, especially the Golden Horde era I do. My areas of concentration are 17th century astronomy, pre-17th century alchemy, Mongol persona, and heraldry. I have a website down on the bottom that has a lot of useful information, such as a bibliography and things of this that may come in useful later. My handout for this class is usually a bibliography anyway, because this is kind of a survey of what you can do with astronomy in the SCA. We're briefly going to go over history, astronomical theory, a lot of the tools that were used, and different things you might can do with astronomy. I always like to start out with the questions like, what is period astronomy? So we can kind of figure out what we're talking about. Well, in the SCA, we would create life prior to 1600, give or take. And so we're obviously looking at that kind of time period. And in the SCA, we research all the way up to the pre-17th century. Astronomy comes from two Greek words, um, which roughly translates into something like star law. In it, there's a lot of different ways that people have looked at astronomy, kind of like in an agricultural sense, like in popular almanacs, like the Farmer's Almanac we have today. This was done throughout period. Also, it was done as a science to study the heavens, to see their outcomes. And of course, astrology was something that was done um, within our period, where we look at what's going on in the heavens and relate it to outcomes that happen here on Earth. So, for our purposes, period astronomy is going to be recreating the celestial study of any of the centuries prior to the 17th. So I'm mostly in this class taking the scientific view. Period astrology would be a different class for me, though quite often it would be studied together in the Middle Ages. Um, and this is done with an aim of recreation, where research is active and not just something we read about. Um, if we stop at 1600, we are working in the pre-telescope era. So there's almost no need to mention telescopes in this class, although I'll mention them a little bit because we all consider telescopes vastly interesting. Um, but the telescope era just really comes in at the tail end of our studies. Things you can do with medieval astronomy. Of course, you could stargaze, you could make star maps, you could navigate your seafaring ships, you could build different medieval instruments used to study the skies, you could write handy star poetry, you could make almanacs for your kingdom so that your fellow Scadians would know the proper times to plant. You could know the omens and you could predict the dire warnings of the death of the royalty in 6 months. Um, you could live in the harmony of heavens and do things as you were intended to do. And the sky is really the limit with what can be done with astronomy. Astronomy can be added to just about any persona in a organized way. Um, we should start off, I think, by looking at the base astronomical theory. Um, until you could look at you could look at astronomy from a Chinese perspective. You could look at it from a Western perspective. And you could look at it from an Indian perspective. These are the major different kinds of outlooks that would probably be around in our period. We're going to be focusing on the Western perspective, which started in Mesopotamia, continued into ancient Greece, was picked up in the Islamic world, and brought back with the Crusades into the Renaissance in Europe. And this is the standard progression for just about all of the sciences that in our Western tradition. And from the time of the ancient Greeks all the way up until the 1700s, there was one major outlook of astronomy, and that was the Ptolemaic view of astronomy by Claudius Ptolemy. And that's the major perspective which we will be viewing. We'll talk some about what comes before Ptolemy and some of what comes after Ptolemy. And while no one was needed to be a slave to Ptolemy's theories, certainly if you wanted to be an astronomer, you started with Ptolemy. So some basic concepts about the medieval view that we're looking for is the Earth was considered to be the center of all things. And this is the same perspective that we have in modern surveying. Surveyors here on Earth today look at their position on the Earth as the center, and they go from kind of there. And that's the kind of same perspective we will be taking. I'm going to stop sharing for a moment to introduce the celestial sphere. Let's see here. Can anyone see this kind of plastic globe thing? Let's see here. Uh, Everybody see this okay? This is called the celestial sphere. And while this is a modern thing that people use in astronomy classrooms today, it perfectly shows the medieval idea of the world. In the center, you have the Earth. You have the sun as this yellow ball that rolls around. And then you have the plastic, the clear plastic edge that contains the outer background of all of the stars. And this would be the medieval view of the world. However, they had giant rings on this that they talked about. One was this ring of this equator here, or the horizon. This metal bar here is the horizon. The equator is actually this big, thick plastic ring you see here that runs all the way around here. There's another ring called the ecliptic, which runs around the globe, and it is the path of the sun. It's the path the sun does. Now, there are different constellations that run across the path of the ecliptic, and these are called zodiac constellations. All the familiar signs of the zodiac are here, Leo and Cancer and Gemini, and whatever, when the sun is in, like, let's say, the constellation Sagittarius, that means that that's where it is on the ecliptic, and those people who, you can't see Sagittarius on that month. So when the sun is in Sagittarius, it's roughly December, and that's why people who are born in December are called Sagittarius, because that's where the sun is on its ecliptic path. Now, Sagittarius cannot be seen during this time at night. So if you wanted to see what stars were up at night when the sun is in Sagittarius, you could just flip it over to where the sun is below the horizon, and then these will be the stars that will be open that night. And that's kind of how that works. There are two other kinds of rings I want to talk about. There are the tropics, which is 30 degrees above and below, and then there's the Arctics, which are up here. And we have these basically same rings on our globe today, and these are the view that we generally, that the medieval people thought of the world. Let's see if I can reshare my screen to get back to my slideshow. There we go. So we've talked about the ring of the ecliptic, which is the sun's path, the tropics, the equatorial line, the horizon. If you look in this picture here, if you see my mouse, this big ring that goes around it would be considered the prime meridian. And so you have this outlook, which is our celestial sphere. Here's another version of it, maybe easier to see. You have your Arctics, your tropics, your equator, more tropics, more Arctics, and then the prime meridian going down for. So you still have this kind of view of the sky. This particular map is from 1660, and it's from a period book. But it shows us also the ecliptic here as a band with the different signs of the zodiac on it, so we can kind of see where things are. Also, if you look in the background here, you see that there are the seven wanderers, or the different things that move in the sky. All the stars were considered to be fixed at the same position away, but we knew some things were closer and some things rotated differently. So you have the 5 planets of Mercury, Venus, Jupiter, Mars, and Saturn, and then of course you had the sun and the moon, who are roughly considered in the same vein, but because of their different motions, were also looked at separately. Now, I'm not getting much feedback from people, so how are we going? Does anyone have any questions? Everything going good? All right. So now to attack some maybe presuppositions. One of the things that people believe about medieval astronomy and the people in the Middle Ages and Renaissance was that they thought the Earth was flat. Our earliest documentations from the Greeks in the 5th century, pretty much everyone since that time who was scholarly and trained in astronomy knew that we lived in a sphere. The people who may have thought the Earth were flat were for the most part either pre-Greek, like pre-Aristotle, or just not very knowledgeable in how the heavens moved. Um, the Mesopotamian and Greek fathers created a very intricate mathematical system of how the world worked, and they could explain everything from their mathematics and their models. And so the question of whether the Earth was flat or a sphere was not even a consideration for these people. You may have had one or two scholars talk about a flat Earth, but for the most part, it just wasn't a thing. Um, you have this Greek person called Eratosthenes of Cyrene, who had measured the Earth's diameter. Also, Aristarchus of Samos had measured the Earth's diameter with great precision. And so these people knew that the Earth was a sphere and that this was just the case. Our flat Earth errors mostly were published between 1870 and 1920, and these were mostly popularized by authors like the author of Sleepy Hollow, Washington Irving, who wrote a fictional autobiography of Christopher Columbus, who said he came to America to prove the Earth was round, and that everyone believed the Earth was flat at that point in time. And this is just myths created by these historians and authors that educated people of these time periods would not have believed. Now, of course, I'm not talking about uneducated people, but I'm talking about people who navigated the oceans and people who studied the stars, and even royalty to a great extent. In the Middle Ages, you'll notice that often kings and queens hold these round balls in their hands with crosses on top. And these are meant to indicate the power of the world and that God has control over the entire world because the cross is on top of it. But the power in this world is held in the hand of the king. And so, but the king is holding a sphere and not a dish. Um, but I know these days that there's a lot of popular conception that the earth is flat and that there are issues with this kind of thinking. Does anyone have any questions about a flat earth and a spherical earth at this time? All right. Now, another, another great objection to medieval astronomy is that the Earth is considered to be at the center of the universe, and that the stars are all considered to be at the same length away. If the ancient astronomers were so intelligent, well, why did they believe two things? Um, and there's this thing that the Greeks and the medievals and the Mesopotamians were looking for called parallax. Parallax is an apparent shift in views between the background of distant objects. So if one object is closer than the other, and you look at it from differing positions, there should be a shift in the positions of the object. Um, this is a geometrical fact that people knew way back in ancient Greece, and they looked for it. And they looked for parallax all the way up till like the 1800s and were not able to find it. And the issue is that just the stars are so far away that parallax cannot be observed without very, very modern, very, very large telescopes. And so they were looking for the right thing to prove that the stars were different distances, but they just did not take into account how far away they were. Um, but stellar parallax is what we use now to determine the distance of planets, and is a major issue in this case. Also, starting concepts of Aristotle's and the Greek astronomers was that the Earth is at rest in the center of the universe is finite, the universe is changeless, the universe's motions and celestial body are uniform and circular. Um, and all of these things were starting presuppositions by Aristotle. Astronomers did not blindly follow them, and astronomers did not feel that they were glued to them, although these were their starting assumptions. There were some Greek astronomers, for example, who argued that the sun was actually the center of orbits and not the Earth. But these people came to these conclusions with the observation they had, and not necessarily with their starting assumptions. Now, one of the things that people may worry about when they're thinking about astronomy is they're thinking about, oh no, I'm going to have to study a lot of math. And depending on what you want to do with medieval astronomy, you won't necessarily have to learn a great deal of math. Um, a lot of things can be done at math with astronomy with just adding, subtracting, multiplication, division. Um, now, get if you buy the wrong book, um, like a very good book about period astronomy, um, it will probably have a lot of trigonometry in it, because trigonometry was the math used that the Greeks used extensively to determine a lot of the things they knew. But most of the necessary math is just stuff like angles and degrees and altitudes and things that people can do relatively easy on their own. Um, Another issue is that modern people might have is that they don't want to learn astronomy. Um, and You probably don't have to learn anything about astrology that you don't already know. Um, I mean, this was a part of normal astronomy in the period, but if you're not interested in it, you wouldn't have to learn about it, and you might find it fascinating to find the kinds of things that people associate with that. Um, the three wise men were in the Christian Christ birth narrative were were expert astronomers in their day, and they were using astrology to kind of follow the points to heaven. But people associated all sorts of good and bad omens with the stars and things that happen there, and so that is certainly something that could be explored if you were interested in. But it's not anything that would be necessary for you to study period astronomy. Another thing that you might think about is, well, feng shui. If I get into Chinese astronomy, maybe I'll be forced to uh, rearrange my house based on my tent at events based on the Chinese proper interpretations of motion and movement. And if you study Chinese astronomy, you are no obligation to rearrange yours or anyone else's tent or cabin. So fear not. I guess we should move on to the historical survey now. We've talked some about it already, but there is this path that all of the sciences seem to take in a period, and they all went from Mesopotamia to ancient Greece to the Islamic world to back to the Renaissance and medieval world in Europe. And this path has kind of happened with astronomy, which led it. I mean, alchemy, which became chemistry. It happened with astronomy. It happened with medicine. This is kind of the path that we're all looking at. Babylonian pre-Hellenic astronomy was focused on being a system of meticulous observation and interpretations. Um, it was state-sponsored astronomy. These were kings and governments who were doing this, and they had constellations and even astrolabes, which are fancy devices for calculating the positions of the heavens. And they combined religion with mythology, and they paved the way for Greek astronomy. The Babylonians particularly were very, very interested in the motion of the planets and had developed a very in-depth planetary system. I would also say that that pre-Hellenic astronomy was very, very closely tied to meticulously recording observations. Um, Most of their advancements came from studying exactly where things were, when, and how it changed throughout periods of time. The Greek astronomy stood on the shoulders of the Babylonian astronomy and invented the Ptolemaic system of astronomy, which we have been talking about. The Greeks, however, were kind of maverick, and they favored philosophy and equation over observation. Um, they created a lot of tools to learn where things are. They invented trigonometry so they could mathematically explain astronomy. They also considered astronomy to be a subdiscipline of mathematics. And they generally did things by saying, oh, well, that's there. Let's see if we can create a formula for where it's going to be tomorrow. Or, all right, there's this much difference between these things. What can we learn about it from that? And this kind of, I don't want to call it lazy, but they didn't meticulously record observations of where things were, though they inherited the Babylonians' observations, and so they used their observations to create systems, equations, and reasons for why the stars moved in this particular way. And so they were able to do things like discover the diameter of the Earth. They were able to do things like discover the angular size of the sun and moon and their approximately distances from the Earth. and to figure out why the planets move the way they do to much greater precision than the Babylonians did. The Arabic um, astronomy, or the Muslim astronomy, however you would like to phrase it, combined Islam with Greek astronomy, and it brought things to new heights. Science was of the utmost important under Islam. And when we call it Islamic astronomy, you shouldn't necessarily think that all of the people who practiced it were Muslims. Jews, Christians, and Muslims all practice Islamic astronomy, and the religion that and the state were the two factors that defined this particular kind of astronomy. Um, they built great observatories. They continued to work on the mathematical side of astronomy, and they were much more interested in meticulous recording than the Greeks were, though they did not abandon the Greeks' love of trigonometry and math to short their observations, or to make shortcuts in their observations. And of course, they passed on astronomy to the next generation. Now, the medieval Greeks, or when astronomy reached medieval Europe, it combined Christianity with Greek astronomy and brought the sciences to new heights. At first, before the Crusades and before the Renaissance, the astronomy was not very good in Europe. Um, there was a couple things that were known and a couple of bad astronomical tables floating around, but it didn't really have the precision of the precision that the Arabic astronomy and the Greek astronomy had. One of the reasons for this is Ptolemy's Almagest, which is the culmination of Greek astronomy, um, was not yet translated into Latin. The church became the authority in astronomy throughout most of Europe, and the Arabs were much more like the Greeks than they were like the Muslims and the Babylonians. They were much more concerned with trying to um, be maverick and think on their own and create shortcuts. Um, Pliny's natural philosophy was very popular at this time, and as far as astronomy speaking, it was very, very poor. It's not until you have the Almagest translated into Latin that the medieval study of astronomy really starts to take off and become something of value. In the Renaissance, we have the world's largest observatory that was built in the Vatican. Astronomy became more Greek, and slowly the Ptolemaic system started to fade. The church control of sciences started to weaken, inventions of the tools expanded, and the telescope appeared by the end of the Renaissance. Now, I was talking about Ptolemy's Almagest, which was written in the Greek period, and this basically means like masterwork. And it was the culmination, like I said, of Greek astronomy. And when when the Muslims took over astronomy from the Greeks, and that's where science kind of focused, the thing that really started it for them was the translation of the Almagest. And Alchemist actually is more, the word is more related to Arabic than it is related to Greek. Um, the title in Greek is something somewhat different, more like the 13 books on the motions of the heavens by Claudius Ptolemy. Um, but alchemist means like masterwork in Arabic. And so once the Islamic world inherited the alchemist, um, that's how you became, well, even in the Greek world, that's how you became an astronomer. Anyone who was to become a scientific astronomer studied the alchemist. It wasn't until you, after you finished and you understood the alchemist, that you could start doing work on your own in a substantive kind of way. And that's why it was, the Crusades, when the alchemist was brought back to Europe and translated into Latin, that medieval astronomy really started to become something of note. And like I said, none of these astronomers felt confined to rest with the alchemist as far as their studies were concerned, but it's what everyone started with. Now, the Alchemist was somewhat of a complicated book and became more complicated over time. So, while astronomers in ancient Greek often started with Alchemist, um, in the Arabic world and in the medieval world and in the Renaissance world, people often studied uh, other texts in order to prepare them to study the Alchemist. And these were like primers and things, and kind of like pre-alchemists. Um, but it wasn't until you reached that level of proficiency that you really became an astronomer. Now, The geocentric worldview, which means that the Earth is center of the universe, changed to the heliocentric worldview, which is the sun is the center. In the Renaissance, and we have to think this Nicholas Copernicus. And you might think that Nicholas Copernicus is the last great astronomer in the Ptolemaic tradition, because while he changed the center of the Earth or the universe to the sun from the Earth, for the most part, in every other place, he went with Ptolemy. He was a student of Ptolemy. That's where he learned the sciences. And the Revolution of the Heavenly Spheres, which is his book, is reworking the alchemist for the sun being the center as opposed to the earth being the center. And so that's kind of like a brief survey of how the how astronomy happened in the Middle Ages. Now you also have Chinese astronomy. Chinese astronomy is a completely separate tradition that owes nothing to the Babylonians or the Greeks or the Arabs or to the Christians or to any Europeans. It, for the most part, was an entirely separate tradition. It started to mingle with what I called the Western tradition earlier, um, when the Mongols had taken over and they had created their vast empire. Um, Mongols loved astronomy, and so they often um, plopped Arabs, Europeans, and Chinese experts together to study. And so there was some cross-pollination in that period, but for the most part, Chinese astronomy is its own system. It also is a meticulous tradition of observation and interpretation. Um, they have pretty much almost every odd occurrence in the sky recorded um, from the time they started, thousands and thousands of years and thousands of data. And the Chinese have meticulously preserved these observations and records, and no one could probably study it all. Once again, Chinese astronomy is state-sponsored. Um, its primary function was the calendar, and how everything was going to function within the Chinese empire. They really wanted to know when to plant, when not to plant, so they could produce enough food to feed all of their people and to promote harmonies in the heavens. They wanted to know if there were going to be droughts or if there were going to be any sorts of other things, and astronomy was the way that this was done. Astronomy and math were also very strongly tied together during this period of time. Um, it's an ancient surviving tradition with its own constellations and its own peculiarity. And you, I mean, its own names for stars, its own way of interpreting things. It's a completely different thing, though it's very interesting on its own, and I encourage to study. All right, before we move on, um, I know that I'm just seeing a bunch of boxes here. Um, is there any questions? I'll pull up the chat so that I can see what's going on. Um, are we good? Can we move on, or does someone have something maybe they would like to add, or something that they would like to comment on? Question? Okay, very good then. Thank you for the feedback, and we will continue. Let me see if I can share the screen again. All right. So moving on, there's a lot of different tools that were used to study the heavens. One of the most famous observatories built in the Renaissance was that of Tycho Brahe's. This drawing on the left here is what it was supposed to look like. The drawing is from around 1595. Today they have a replica of it, which we can see on the right, um, with all sorts of different buildings with different shutters. And these, the purpose of these is kind of like the same purpose that we have these domes for our telescopes. Not that they were being used with telescopes, but that they wanted to observe the light of just a particular portion of the sky. And they wanted to be able to say, well, I'm looking at such and such an angle of the sky, and this is so many degrees. Um, and this way they could observe the rotations of the stars, things of this nature. So it's one of the most interesting kind of or famous observatory picture to kind of see. We're talking about tools. The most famous thing that people think about is probably star charts. Here are some different ones. This one's from around 1515. You see several of the constellations that we are familiar with, Leo and Cancer all around the ecliptic in this circle. You have the things that are inside the ecliptic, and you have some things outside the ecliptic. And you see how they've put the stars on the drawings of the things themselves. And so these kind of things were common illumination inspirations, as well as things that people would use to learn to try to figure out where things were in the heavens. Another kind of star chart, although very different. Um, in the center here, you would have the Earth, and then outside, you would have each one of these different colors is one of the orbits of the different planets, and you have physical things to represent them. And outside that, you have the zodiac, which we once again saw in the other form. Then you have the phases of the moon, and then you have different constellations that were known in stars. This is a medieval Arabic piece, and it's from around 1583. Um, Here is another kind of star chart. This is a Chinese star chart from around 1020 to 1101. As you can see, this is much more scientific looking. Um, and you have once again the stars going around, and you can kind of see the perspective of what they look like, and you see the writings identifying them. And so star charts were kind of an easy way for you to know. Um, Star charts and tables were kind of an easy way for you to know if people were doing actual astronomy. If they didn't have tables and star charts, they probably weren't doing astronomy. But if they had tables and star charts, to some extent, true astronomy was probably being done. Tables, of course, instead of being shown graphically, are just a list of star names with their altitudes, their zeniths, and all of these kind of things. Um, but they're very useful tools, nevertheless. The simple and most basic tool of astronomy that astronomers have been using forever, probably the first astronomical tool, is the gnomon. The gnomon is basically a vertical stick used to make shadow plots of the sun. Um, Now, if you're taking account of where the shadow ends, different parts and times of the day, it's going to make kind of like this curve. And the shortest shadow of the day is always local noon, and is always also points the direction of north, at least in the northern hemisphere. There are other places in the world where that's not true, but for all the continental U.S. and I believe for Europe, that holds very, very well. Um, so the compasses that we have today do not point true north; they point to a magnetic north, so that there is a angular difference between true north and magnetic north. You can always find this by creating a vertical stack and pointing out different dots for different points of the time of the day it does. Uh, the noonday plot will be the shortest point, and we'll look at that more in future lessons. But a lot of things can be learned from gnomon. You can know about the solstices and the equinox and the path of the sun and local time. There used to be this thing called seasonal hours. Like we have these mechanical clocks that tell us our time now. But times were divided into equal divisions of time. So you had 12 hours of daylight and 12 hours of nighttime each time. But daylight was divided equally into 12 hours, and the nighttime was divided equally into 12 hours. So in the winter, the nighttime was longer, and in the summer, the daytime was longer. And so um, true noon or local noon and 12 o'clock very rarely coincide together, astronomically speaking. But if you know when local noon is, it can be a useful thing, astronomically speaking. Also, gnomons are the center part of sundials, which we use to tell the time. And so they are used all over the place. So there's this other thing called a nocturnal or a night dial. This was especially used by sailors and astronomers for telling time at night. These can be as simple as spears. Sometimes they can have these kind of sawtooth things on them and some sort of reed. And basically, there's numbers on it, and you use the Polaris and the Little Dipper, and you can tell what time of day it is seasonally. And even to our time, if you take into account daylight saving time, within an hour or so of our clock time, you can find out what time it is. It's very useful because if you're trying to plot down the stars at night or find out what's going to be up when, or you need to be able to have some way of determining, okay, well, about what stage of the night are we in? Um, and so a night dial or a nocturnal can be used for that purpose. There's also this thing called the diptora. It's a surveying tool. It's basically just a sighting mechanism. You have compound diptorals and you have diptorals. Diptorals, you can have two loops separated, or you could have a tube, and you keep that fixed. And a diptoral can be used to prove that there is diurnal rotation of the Earth, which is what diurnal rotation would be. You just place it at a sextant and you don't touch it, and you look at it and you find a star in it in an hour, and you come back in an hour, and you'll notice that the star is no longer in your sighting tube. You can easily see that the background of stars is moving in this way. And so you can use it in this way. If it's a compound diptoral, it has two sighting things, and these things often are combined with the angles, so you can find out how many angles or how many degrees something is different from each other. The one in this picture here is a Roman diptora. We also have the camel. The camel is of Arabic origin. It is basically a card or a slat of wood on a rope, and there are knots at different types or different places on the string. These things would be used for navigation primarily, but they can also be used to determine angular distance. Basically, if you hold your thumb out, you'll notice that it's at different places when it gets there, and you can determine different angles. So each knot would be a different amount of degrees. The first knot might be an angular difference from your vision from the knot of 10 degrees. Maybe the second one is 20 degrees. It's kind of a predecessor to the cross staff, and it's very, very simple for use in sailing. Then we have, of course, the cross staff, the radius astronomicus. It's of Jewish origin, and it works the same way, except for instead of having a rope, you have this long stick. And the angle from the sight of the bottom of the stick to the top of the stick here kind of shows you each is set for a different angle. And you have different slots that put on it, so you can determine the different angles of things. On the right, you have this gentleman who is determining the angle from a sun from another object, and it shows that usage here. This is a quadrant. It is the grandfather to the sextant, and it's simply used to determine how many degrees something is from the horizon. You need two basic angles to determine whether things are where things are, how many degrees from north it is, and how many degrees in the sky it is from the horizon. And you can use this to solve both of those kind of problems. We also have the armillary sphere, which is the skeletal version of the celestial sphere. We talked about it earlier. It shows the ecliptic, the equator, the prime meridian, the tropics and the Arctic, and the horizon. And it's used as a teaching tool, as well as it's used as a tool for dividing the heavens. One of the most common tools in the Middle Ages. One of our most famous medieval tools is called the astrolabe. This is an astrolabe. It is a disc, and it is used to determine the risings and settings of stars and the sun throughout the year. It can also be used as a quadrant, and it is very, very useful. It's probably one of the fanciest kind of astronomy tools and one of the things that everybody loves. The next class at, what time is it? In just a few minutes will be about the use of the quadrant in the astrolabe. We'll discuss what all the parts are and how these things are used to be able to start making basic celestial observations. This is a torquem. It is a combination of a diptoral, a quadrant, an astrolabe, and several other things to work as an analog computer between coordinates. You really almost need one of these things if you're going to do much of a almanac. But these things are very useful in their use for determining eclipses and things of this nature. The Chinese were the first to invent the compass. It's useful for aligning the observation and navigation. There are several different period models. This is a version of a period compass. Again, you have to keep in mind that there is a difference between magnetic north and true north. And so this can only really point you to a magnetic north. And you need to know the difference locally so that you can have your data points fixed. This is a water clock. These were used in Egypt, Babylonia, India, China, the Greco-Roman period, Korea, Arab countries, and in Europe. They helped divide things into specific times. Again, this would have been seasonal hours and not like mechanical hours like we're thinking of, but a very useful tool, and timekeeping tools are often useful in astronomy. We do have telescopes towards around the 10th or 11th century. There's a work written by Ibn Sa and Ibn al-Haytham, who started doing optic studies. These optic studies did not really come into telescopes like we think of until around 1608, when there was this person named Hans Lippershey who made telescopes along with Zachary Johannes and Jacob Mitius. These things were mostly used for sighting on ships and were not specifically used to look at the sky. The first person who used them to look at the sky, as far as we know, is Galileo. And he was the first astronomer to think that these things would look different if we looked at them closer, because the presuppositions of the medieval astronomy were that it wouldn't be useful to use a star to look at them since they're all at fixed points. But Galileo did, and he noticed that that there were risings and settings in Venus, which meant that Venus wasn't really orbiting the Earth, and that he noticed that Jupiter had 4 moons, and Jupiter's moons were not orbiting Earth either, so that Earth became not the center of all orbits, and with phases for Venus, we knew that Venus did also not have to orbit the Earth, and so those were some of the big things that led us away from the geocentric worldview. There are lots of other different kinds of
Hey,
scientific.
Karen, I just wanted to give you a 10-minute warning.
Oh, thank you. It's very kind. Um, there are other kinds of medieval astronomical and navigational instruments that were used for astronomy: backstaffs, celestial globes, which are kind of like globes of the Earth, except that they have the heavens painted on them. You have the Antitheka mechanism, which is a famous Greek find, kind of a mechanical wonder. You have other astrums and astronomical clocks that people have used throughout the centuries. These things can be looked up for those of you who have interest in them. A lot of poetry was written about stars. There's things in Homer's Iliad and something around right after Homer's Iliad called Hesiod's Works and Days that all talked about the spring and the seasons and how you could determine the seasons from the stars. Famous poem called Plough Star, which is translated Mul Appen from the Babylonian, and of course it was about Sirius and or not Sirius, Polaris, and it was a very I'm butchering myself here. It was about Sirius, um, which is the brightest star in the sky and very useful for astronomical things. So poetry is an option for doing things with astronomy. Um, the Celtic world and the world of Europe had lots of stone circles, dolmens, and earthenworks. These things are often used for ritual calendars, and they're usually set up with solstices and equinox and different kinds of astronomical events. The 2 key words, if you're interested in studying these things, are archaeoastronomy, which is the combination of archaeology and astronomy to interpret these ancient sites, and ethnoastronomy, which is the look at astronomy within particular cultural settings. So if you're looking to study astronomy more, these words are certainly important. Now, Mongolian yurts also are somewhat set up according to the heavens. The doors were always south, and each section of the yurt had a different zodiac ruling. Of course, I put this in here as a shameless plug of the Mongol people. There were lots of different almanacs and calendars that were made from the study of astronomy, and this is probably the most famous use of it. Now these are the 2 books that I would recommend. If you're really looking to get started in astronomy, you need to really start with these 2 books. The one on the right is The History and Practice of Ancient Astronomy by James Evans, and the one on the left is Ptolemy's Almagest. Like I said, in the Middle Ages, if you needed to be an astronomer, you needed to study the Almagest, and I think it's no different for an SCA astronomer. But I don't think most of us are capable of reading the Almagest and getting anything out of it to start with. But Evans, The History and Practice of Ancient Astronomy, is a good overview of Babylonian, Greek, medieval, and Renaissance astronomy. And it kind of walks you through the basic principles. After you have read and worked through this book, you should have no problem reading and studying The Alchemist. The other nice thing about the Ancient Astronomy book is it's written by a modern person, so it's very friendly to read compared to The Alchemist, and it has lots of practices, things you can do, and examples that will help you understand this thing a lot better. And then Ptolemy's Alchemist is very dry reading, because was written in ancient Greek and translated into Arabic, and then translated into Latin, and then translated into English. And so this isn't something you read to while away the day. You read this with your pencil and a paper and try to understand the trigonometry involved. And so, but these are the two books that if you want to be a serious astronomer that you need to look up. Also, my website, let's stop my sharing here, has a lot of bibliography sources that I want to go over real quick. Share screen the other way. Okay. This is my website, astrogur.blogspot.org. If you click on astronomy resources, I have here an article about how to get started studying medieval astronomy. And then I have a whole annotated bibliography with web links and books that can kind of let you know what the books are and if there's something you would be interested in and how to get started in general. And so I would hope that you guys would find those things useful. Now, I know that we only have about 4 minutes left according to my clock, maybe less according to other clocks. But I said a lot of things and I didn't get a lot of feedback. So is there any questions, comments, or snide remarks? Okay. Let's see here. The next class will start, I guess, at probably right around 12:05. And it will be about quadrants and astrolabes and how these things are used, and a little bit more about the Ptolemaic view of the world, which they are used to interpret. You're welcome, Lycia. I hope it was good information. And like I said, this is intended to be kind of a survey. So the next class is going to be more hands-on. And then the next two classes after that are going to be theory based on the information that hopefully we have in this class and the next class.